Programming, or Notes on Making Program Structure More Informative. Foreword. I don't usually write about programming as it sounds like gibberish, but with the availability of language model AI, programming became a little bit more approachable for the novice programmer. It just needs one tiny little thing, a helpful 100 or 300 lines of code WikiWiki that will host the description and corresponding code. Writing a WikiWiki for the purpose of computer program description and potentially nearly automatic creation is a great invitation into the world of programming. It is learning programming by starting with creating your own artificial intelligence-backed code editor. Writing a WikiWiki of any flavor makes for a wonderful and pleasant entry into the world of programming. Programming. The user interface is a massive unsolved problem in the strange world of programming. Currently, there are 3 levels in which application programming can work. Level 1 is the code editor level, where all the program files are simply stored in a directory structure. Level 2 does away with directories, and code is written atop a concept of a notebook, or a code journal, or basically a WikiWiki. Level 3, a graphics-based approach, where boxes with properties represent code functions and are connected by lines, forming a graphical representation of a program and its various flows. I want to clarify that visual programming as it is used here is not about drag-and-drop user interfaces, but flow-based programming with a graphic user interface. Functions represented by graphic boxes and control flow represented by lines. Level 1 is the safest. There are no real limits here. But even properly structured applications are hard to remember. Level 2 combines concepts of literate programming, WikiWiki, code journal, and code notebook, and documentation-first approach. It is much harder to get lost here. And level 3 is unfortunately a kind of a broken promise, as it requires a large ecosystem, multiple programmers, and a clear head to get it quite right. All implementations of visual programming I have encountered failed to deliver and became bloated with confusion. Visual programming done correctly can almost become a perfect solution. However, a computer program must be represented from multiple angles or with multiple graphs. And visual programming is a manual process that only lays out one angle, one graph, one perspective, and it cannot be easily rotated. Language models or AI could try to do it, but its non-deterministic nature at this scale does not quite solve enough. It is of some note that the graphic user interface should also work on small screens. That, unfortunately, multiplies the complexity of the code base, again making it a multiple programmer project. The problem with level 1 programming, the safest kind, where everything is a text file in some folder structure, is that there is not enough meta information or semantic data about the program structure that the programmer holds in their mind while creating everything. Using cookie-cutter structures like model view controller-based plugins does not solve, but rather deepens this problem by adding more structure and scattering things out without adding the much-needed description. This leaves us with number 2, literate programming, or the WikiWiki-like approach of a journal or notebook. The function description first approach allows for just enough metadata to generate multiple graphic representations of the program, multiple angles where, for example, only image processing related code is plotted on a graph, helping the user focus on what they need to see. These graphs are much simpler than what visual programming normally delivers, and they are absolutely read-only. You can't modify the program by interacting with them. This level 2 literate programming or comment-first programming focuses on text-first, code later. The programming required to create such a system is actually quite simple and extremely inviting, as it is at its core just 100 lines of WikiWiki code. I recommend using CodeMirror for the code editor and Cytoscape.js for the automatic layout graphs that plot multiple perspectives of the program. Language model AI can be used to expand the metadata, and in this context, its non-deterministic nature won't be too much of a problem. It can handle it. On the user interface end, the programming can be either JavaScript rich, where I would recommend Svelte, or, standard HTTP programming as it used to be in the 1990s or early 2000s. You may see that kind of code in the first WikiWiki. I would like to note that when we rise above level 1, the line between code and code execution is allowed to blur. Saving a function can make it, and thus the program, immediately available for execution. In something that can be viewed as a transparent deployment system where the program is edited live and made available under a new revision number or latest tag. In another model, the program that is spread across a tree of functions spanning multiple graphical nodes or WikiWiki pages can be exported as a proper module, a well-formed standalone application that is indistinguishable from what a level 1 programmer would create. Pretty good deal. In conclusion, level 2 is the more correct and informative approach, as it has a small code base and encourages the user to describe the program first. This creates enough metadata to interact with a language model AI that can potentially create the code that is in the description, and certainly contribute useful information to enrich the metadata itself.